Did you know that you can land on Venus without a parachute or a rocket engine? The Soviet Union discovered this amazing fact 50 years ago through a lot of trial and error. Their efforts revealed the true nature of one of the most intriguing places in our solar system. Today on Fact Epics, let's explore what the Soviets found when they landed on Venus and why they never went back. Venera, the Russian term for Venus, was the name of a series of 16 missions from 1961 to 1985 aimed at understanding, discovering, and mapping Earth's closest neighbor. The project involved space probes and satellites sent to Venus, with political implications as one of the USSR's ambitious efforts during the space race. Mars was previously ignored due to lack of observation, while Venus's thick clouds suggested life on the planet. The closer proximity to the Sun and insulating cloud layer suggested a tropical climate with dense rainforests supporting alien insects and reptiles. Astronomer Carl Sagan popularized the idea that Venus's unbroken cloud cover signified a greenhouse effect. The Venus flyby. As with all the early milestones in the space race, the Soviet Union was the first to attempt to study Venus up close. In 1961, the Soviets built two probes, Venera 1 and Venera 2, to explore Venus. Both probes failed due to system failures, resulting in no usable data. In 1962, the Americans successfully completed the first up-close observation of Venus with Mariner 2, which gathered significant data on the planet's atmosphere and surface. The findings confirmed Sagan's greenhouse effect theory, with temperatures reaching 900 degrees Fahrenheit on the day side and a dense cloud layer. NASA decided to focus on the Moon and Mars instead, but the Soviets redoubled their efforts and prepared the second wave of Venera probes. First contact. In 1966, the Soviets built a larger spacecraft, Venera 3 and 4, with over 2,000 pounds of weight and various instruments. The aim was to parachute through the Venusian atmosphere to collect measurements about composition, temperature, and pressure. Venera 3 experienced a system failure, but the Soviets managed to hit Venus, becoming the first man-made object to crash into another planet. Venera 4 in 1967 was the closest to a success story, dropping the capsule into the Venusian atmosphere and collecting measurements inside the atmosphere. The data revealed that Venus's atmosphere is similar to Earth's on a warm summer day, but as the probe descends, the climate becomes more extreme, leading to transmission going dead after 90 minutes of slow descent. This information led the Soviets to believe their remaining Venera 5 and 6 probes would have no chance of reaching the surface. NASA launched another flyby mission to Venus in 1967, Mariner 5, which confirmed the extreme conditions on Venus. With that in mind, the Soviets launched Venera 5 and 6 back-to-back in January 1969. Both probes recorded less than an hour of data each before meeting the same crushing fate as their predecessor. And yet, the Soviet Union was not discouraged in their efforts. They would simply build even bigger and stronger probes, and they were going to try again. The landing attempt. The Soviet Union made two key modifications to their Venera landing attempts in 1970 and 1972. The first was to build a thicker metal descent module with insulation, featuring an internal titanium sphere to protect instruments from heat and padding to soften the blow from impact. The second modification was to minimize the time the probe was exposed to the harsh environment by placing an extra tie around the parachute lines. Venera 7's parachute was deployed on August 17, 1970, but it didn't last long, either getting ripped or melted. Despite this, the lander continued to send back information. The temperature recorded at the surface was 475 degrees Celsius, roughly 900 degrees Fahrenheit, which was too hot for any machine to operate reliably. In 1972, the Soviet Union tried again with Venera 8, which touched down softly on the planet's surface, with all its instruments intact, and recorded data for just under an hour. This confirmed the temperature on Venus exceeds 900 degrees Fahrenheit, The pressure on the surface is equivalent to 92 times that of Earth's atmosphere, and the lower atmosphere is filled with sulfuric acid. Venera 8 revealed that despite dense cloud cover, Venus's surface was illuminated enough for a photograph, highlighting a valuable fact. A new approach. The Soviets made significant changes to the design of Venera 9, focusing on minimizing environmental exposure and ensuring a safe landing procedure. The descent capsule, now nearly 5 metric tons, is now equipped with a new aerobrake, which allows for a safe landing on Venus without the need for a parachute. The landing gear, a flat metal circle connected to the main body by shock absorber legs, and the new aerobrake are designed to take advantage of Venus's thick atmosphere, which behaves more like water than air. The probe's camera system captured the first photograph of Venus in 1975, showing a field of broken, jagged rocks surrounded by sand-like material. Venera 11 and 12 were less eventful missions, as they failed to return any interesting photos due to lens cap failures. This was due to the camera's need to be protected on the way down to prevent premature melting, and the automated system to reveal the lens, which didn't always work. The new event. Venera 13, a successful 1981 mission, returned the first-ever color photo of the Venusian surface, providing a unique and spooky view of the planet. The probe's base had metal teeth added to reduce spin and oscillation, resulting in a rough landing. Venera 13 also had a drill and surface sampler to analyze the Venusian soil, finding a material similar to Earth's tough, solidified volcanic ash. It also carried a microphone for listening to the sounds of Venus. Venera 14 found another flat plain of smooth rocks similar to tholeiitic basalt, a volcanic rock that makes up most of Earth's ocean floor. This was the last time a man-made object reached the surface of Venus. The Venera program ended as the Soviet Union's leadership and priorities changed, and Russia faced a tough time in the 1990s. As technology becomes more advanced, it becomes more fragile. The old Soviet Union was the perfect place to build a machine that could withstand Venus, but we may have lost that style of craftsmanship in pursuit of cheaper and more efficient manufacturing. Thank you for joining us on this journey into the Soviet fascination with Venus. Be sure to subscribe to our channel for more epic facts. Until next time, keep looking up.